Hello everyone, I welcome you all for this video lecture. We are going to see the buck boost converter in this video session. So let us go see the configuration of different converters. So first we have discussed the buck converter in our previous videos. So when we see the buck converter configuration, the switch is connected in series to the source, and diode is connected across the source, and inductor is connected again in series. Now with the control of the switch, on and off control, or it's a PWM control or frequency control. So the on and off control of the switch, the average voltage of the output voltage we can get across the load, which is lesser than our input voltage. So that is nothing but a step down converter, otherwise it is a buck operation. So whereas we have also discussed another type of converter, that is the boost converter. So in the boost converter, the inductor is immediately connected to the source, which is in series, and the switch is connected across these two combinations, and diode is connected again in the series. Now, so when the switch is closed and open, suppose when the switch is open, first when the switch is open, the two sources voltage will appear across the capacitor, and the voltage output voltage value will be increased than input voltage. So when the switch is closed, again inductor will be charged. When the switch is open, the input voltage and inductor voltage both will be combined together, which will charge the capacitor. The charge capacitor will be given to load. So in this condition, the output voltage V0 is greater than Vs. So the boost operation takes place, or the step up operation takes place in this configuration. Now we are going to see in this video the buck boost converter. So in the buck boost converter, the configuration of this converter is like this. The switch is connected in series to the source, and inductor is connected parallel, and the diode is reversely connected as it is there in previously boost converter in one direction. So whereas in the buck boost converter is reversely connected, and the capacitor as it is connected to the load. So this is the basic configuration of your buck boost converter. So with this configuration, we are going to get both step up operation and step down operation can be possible with this circuit. That's why the circuit can be called as a buck boost converter. So let us see. So what is the different working modes of this buck boost converter? So mode 1 operation. So there are total 3 modes of operation for this circuit. In the mode 1 operation, so the conditions we will consider, that is the switch is on condition and the diode is off, obviously. So when the switch is closed, the diode is reverse biased. So obviously this is a zero resistance circuit, and inductor will get charged with the source, and the capacitor voltage, which is previously stored initial condition, that will be supplied a current to the load. So the switch is on, therefore represents a short circuit, ideally offering a zero resistance to the flow of current. So when the switch is on, all the current will flow the inductor, and inductor gets charged. So the inductor stores the energy during this time, and the switch is on. The diode is reverse biased. The current is continuing with the load capacitor C. Now in mode 2, the switch is off and the diode is on condition. So when the switch is off condition, this circuit will be discontinued, and whatever the polarity which is charged, now inductor polarity will be reversed, but here for convenience the same polarity we have maintained. But normally the polarity will be reversed, and the current will be supplied to the load, and current is charging to the capacitor. So the current will be going to the through load, and capacitor will be load through diode. This circuit will be closed. So in this mode, the polarity of the inductor is reversed, and the energy stored in the inductor in the previous mode, that will be released, and it is given to the load and capacitor. Whereas in third mode, so in third mode, the switch is open, the diode is also off condition. So in this condition, the inductor is also inactive, only the capacitor voltage will be supplied to the load. So the capacitor voltage appear across the load. So therefore we will have different polarities. It's also called as a inverting regulator, because so when you see it, so in this mode of operation we are getting a reverse polarity of the voltage, and in this voltage we are getting a positive polarity. So but we are getting a reverse polarity possible, so that's why it's called it's a inverting regulator. Then the other name for buck boost converter, it is the inverting regulator. So these are the waveforms of different modes which we already discussed: mode 1, mode 2, mode 3. So as we have discussed the mode 1 is the switch on condition. So when the switch is on condition, the output voltage will be appeared as a positive. So the voltage appeared across this one is this, and the inductor starts energy storage, and the current will be is in the increasing mode. And the second mode, mode 2 operation, switch is off and diode is on condition. So when the diode is on condition, the output voltage will be the reverse condition, and the current will be discharged up to 0. And mode 3 operation, both the switch and diode both will be off condition. So on that off condition, only capacitor voltage will be appeared, and the inductor current will be 0. And the same thing will be repeated again. When the again on condition, the current will start again increasing, then the voltage appeared across the load, and again at this condition the switch will be closed, open, and again it will be decreased. So this is the waveforms of mode 1 operation, mode 2 operation, and mode 3 operation. So mode 1 operation will be continued up to the time period of dt. So total time period of this cycle is t. Now we'll see the analysis of mode 1, mode 2, mode 3. So let us consider the switch is on in T on period and the switch is off at T off, and we'll define the total time period of the one cycle is T on plus T off, and the switching frequency is, so obviously the 1 by T is the switching frequency. Now let us know the duty cycle, how much time it is on. So it's D is equals to T on by T. So let us analyze the buck boost converter steady state operation by applying a simple KVL. So your input voltage is equals to VL in mode 1 operation. So when you observe the mode 1 operation, the diode is open circuited and the switch is closed, and whatever the input voltage which is appeared across the inductor voltage. So input voltage and inductor voltage both are equal. So V in input voltage and inductor voltage both are equal. Therefore, your inductor voltage VL is equals to L into DIL by dt. So that value is equals to your input voltage Vn. So DIL by dt is equals to, therefore it is a change in IL by change in time. Whatever the DIL means, it is a change in inductor current with respect to time. So delta IL by dt, change in time is dt, it's equals to Vin by L. So the change in current by change in time is equals to Vin by L. Now, since the switch is closed for time t on dt, at dt the switch is closed. So delta IL closing condition, the value of delta IL is equals to V in by L dt. Now while performing this analysis of buck boost converter, we have to remember one thing. So the continuous conduction mode and discontinuous conduction mode of the current depends upon your inductor value. So if you are properly designed your inductor value, you can achieve a continuous conduction. For generally higher rating of inductance values, will get a continuous current, and for lower rating of L value, you will get a discontinuous mode of conduction. And the second point we should have to remember, the inductor current in steady state rises the value in mode 1 operation, positive slope. So it's the maximum during the on state and drops back down initial value at a negative slope. Therefore, the net change in the inductor current may be a complete cycle of 0. So this one is the mode 1 analysis. Now let us see the mode 2 analysis where the switch is closed and the diode is on. So let us now analyze the buck boost converter steady state operation in mode 2 by applying a KVL. See what will happen in mode 2. So inductor releases its energy and your VL value gives to the V out. So we can see the inductor voltage value is equals to output voltage. Therefore, VL is equals to L into DIL by dt. So that value is equals to the output voltage. So DIL by dt is equals to change in current by change in time. So change in current is delta IL. Change in time is it is off period is 1 minus dt. So V naught by L. Since the switch is open for the time T off is equals to T total time period means on time. So T minus dt. So it is 1 minus T. So we can say this is the delta T value is 1 minus T, which is substituted here. Now, so we'll see it is already established that the net change of the inductor current over any one complete cycle is 0. So it will reach to the 0. So closed time and open time change of current is equals to 0. So closed time, the value of delta IL is equals to V naught by mode 2. So V naught by L 1 minus dt plus in on time mode 1 operation V in by L dt is equals to 0. So we'll see the output input relation from this. So V naught by V in is equals to minus d by 1 minus d. So this is the output and input relation. So based on this relation, we know d varies, duty ratio varies between 0 to 1. The d value can be varied from 0 to 1. If d value is greater than 0.5, so that means 0.5, half of the value, on time is greater than half of the value, then the output voltage is larger than input, then it's called as a step up operation. So if this circuit, if it is operated as a step up, then the duty ratio on time is greater than 0.5. Now second condition, if the d is less than 0.5, then the output is smaller than input. So but if d is 0.5, the output is equals to input voltage. So let us see, substitute the d value 0.25, and we'll see 0.25 by 1 minus 0.25, so 0.25, 0.75. That means it is a step down operation. So otherwise you substitute d value 0.75 by 0.25, so it is a higher value, then obviously it is a step up operation. So the operation can be differentiated based on the value of d value, that is the duty ratio value. Duty ratio is nothing but turn on time to turn off time. If you increase the turn on time, then duty ratio will be increased. If you decrease the turn on time, duty ratio will be decreased. So that is the operation, how we can operate this circuit for both operations, buck operation and boost operation. So we'll see the same buck boost, it is a boost continuous current mode of operation. So in continuous current mode of operation, you can see, so it will be your inductor will be charged in mode 1, and in mode 2 the inductor will be discharged, but the complete energy will not be discharged, because so it has a very high value. So the time taken to discharge the current is high, so obviously it will not reach to the 0 immediately. Next cycle mode 1 starts. That means in continuous current mode there is no mode 3 operation, there is only mode 1 and mode 2 operations. In mode 1 the current will be raised, and mode 2 the current will be dropped, but it will not reach us to the 0. So this is the voltage values of output voltage, and switch is on condition and switch is off condition. So thank you very much.